Okay, answer the following questions about this rational function. And the x-intercepts are relatively simple to do because they gave it to me in factored form over here. And by giving it to me in factored form, it makes it easy for me to deal with the problem. So the x-intercepts are going to be when the numerator becomes 0, and that happens at 1, just a point, and the other point is at 2. Let's get a red pen out, see how we got those answers. And I got that. What's the next question and answer? What's the y-intercept? Relatively easy to do. Just set x to be 0. I would probably do it right over here, by the way, because it's the easiest for me to do that, and that would just give me 2/3. All right, let's get a red pen out, see if we got that answer right, and we did. All right, the equation of the horizontal asymptote, I want to point out it's probably a good idea to write down the limit, but they're relatively easy to do, by the way. Goes towards infinity. Divide by the highest degree variable, which is x squared. What are you going to get? You would get 1 minus 3 over x plus 2 over x squared. You get 2 plus 5 over x plus 3 over x squared. And as x goes towards infinity, this just goes towards 1/2. You could also do the limit as x goes minus infinity. I'm just going to write f of x down now because it's the same thing, divide the highest degree variable, and if you evaluate that limit, it would just be 1/2. So what's the horizontal asymptote? The horizontal asymptote is going to be a line of this form over here. All right, we got our work, and we got an answer down here. Does it match theirs? It does. Now the equation of the vertical asymptote is more difficult, and I want to point out what I mean by that. It's going to be, the candidates for it are going to be x equals, where the bottom is 0, minus 1 is certainly one of them, and the other candidate is x equals, well, it's going to be when that other factor, 2x plus 3 equals 0, and that's minus 3 over 2. All right? As we've been doing these in class, though, I'm going to start to erase some of the work over here. I'm done with this. There's a variety of ways of doing this, by the way, but I want to point out sign analysis is probably an important way, and at least initially. All right? You can get tricked by it, but let's hopefully not going to get too tricked by it. So looking at it, I do know that I'm kind of interested in the sign analysis of the problem, and let me kind of list these things down for you. So I'm going to say minus 1. That's right there. I'm going to say 1. That's I did this one over here. I'm going to say 2. And then what am I going to do? This one over here, which is minus 3 over 2, which is over here somewhere. All right, so I want to, kind of write this down. I realize that, the limit as x approaches minus 1 from the right of f of x, and the limit as x approaches minus 1 from the left of f of x. I know they're going to blow up, and the reason at the bottom is going towards 0, so at least I know it's infinity. I wonder what the sign is, though. All right, so let's take a look at that, and we're going towards minus 1. We're over here. So let's go to the right of it. Let's take a number in this interval over here, like 0, and test it out. And if you tried 0, what do you get? You get positive on top and positive on bottom. So overall, it's positive. Now let me go to the left of minus 1 and take minus 1.1, and you would get, let me make sure I did that right. I'm starting to not doubt myself, but I want to make sure I spoke to that correctly. Yeah, I did okay. So minus 1.1, you get negative on top. Let's see, minus 1.1, oh no, positive on top. And on bottom, you get negative. So it's overall negative. So I'm ready to write this down now. I'll write this over here. To the right of minus 1, it's positive. To the left of minus 1, it's negative. That's done. Let's do the other one. And I got an asymptote over here. I'm going to put a box in this indicating we've done the work on it and supports that. Let's do this one. Limit as x goes towards minus 3 over 2 from the right of f of x. And let's do the limit as x goes from the left of that number. Well, I already know what happens to the right of it. It's minus. Let's see what happens to the left of it. And let's take a number like, I don't know, like minus 2. And what do you get there? A negative times a negative, a positive on top. And on bottom, you would get a positive. So it's going to be plus infinity. So I've got this one supported as being an asymptote as well, all right? Are they being listed here? Let's take a look. Okay, and the graph part, all right? I do want to go through this with you. And going through it, I got to get more sign analysis going over here. And the information we have written down is really sufficient. So as I do that, I want to point out, as you're doing this thing, you want to start with the easy stuff, and I'll go through one thing at a time, but I do want to get the rest of the sign analysis down. So after 2, if you picked 5, for example, you pick any number after 2 you like, you get positive, 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 positive. So it's definitely positive. If you took the number between 1 and 2, like 1.5, you would get negative number. Now, someone says, is this important to know that? It is. So all the information I have down here, I'm going to start to erase some of the distractions. I'm going to erase this too. Okay. I want to point out everything that's written down over here is sufficient for me to construct the graph, but I do want to go to the graph to do it. And we'll look at this over here. The first thing I'll do in the graph is just get these 2 points down, which is 1, 0, 2, 0. All right, 1, 0 is here. And let me see if I did that right. And 2, 0. Put this over here. Boy, it's going to be tough to see that, isn't it? All right. I also want to put down the asymptotes, where the asymptote's going to be. Oh, no, let's put the y-intercept down, 0, 2/3. That's right over here. Okay. Let's get the asymptotes down. It's a tough graph, though. I know that. Y equals 1/2. That's this line right over here. Okay. The other 2 asymptotes we found out were, let's see, -1 and -3 halves. That's x equals. This is the -1 guy, and this is the -3 halves. All right. I think we did the limits, right? And let's talk about that. The limit as you approach this guy over here, which is the -1 from the right, should be plus infinity. And from the left, it should be negative infinity. Let me go back over here and look at that. I'm seeing that behavior there, all right? And then the bottom, I look at the other one. Again, I know I'm going back. This one over here. From the right, it's plus infinity. Let me just make sure I said that right. I'm sorry, from the right, minus infinity. I'm sorry. And from the left, negative infinity, positive infinity. I am seeing that behavior over here. Now, granted, tracing this out might be difficult, all right? I realize that I'm kind of zooming in and out a lot over here, but something like this is connecting information together, something like this. I want to point out over here, something interesting is happening over here. Just looking at the sign analysis, I know it goes below. I know that much. Again, I'm exaggerating. If you really zoomed in, you'd see it below it. It's a minor dip, by the way. It's a tough graph, though. I know that. And I'm going to say that's pretty much done. And everything led to that analysis. Thank you.